6.5 Analyzing and Sketching Graphs. Example 1 Analyzing Graphs. The graphs show the temperatures throughout the day in two cities. We have Belfast, Maine, and Newport, Oregon. As you can see for Belfast, Maine, it goes up throughout the day, hits a peak, and then decreases. Now, while Newport, Maine has a different trajectory where it starts off with a higher temperature, decreases, finds a steady amount, and then increases from there. So we're going to describe the change in temperatures in each city. So I'm going to start with Belfast. For Belfast, the temperature increases at the beginning of the day, then the temperature begins decreasing. At a faster and faster rate for the rest of the day. Then we're going to talk about Newport. The temperature, I'm going to abbreviate it as temp, decreases at a constant rate at the beginning of the day. Then the temperature stays the same for a while before increasing at a constant rate for the rest of the day. So letter B says to make three comparisons from the graphs. Well, if I look at both the graphs, both show increasing and decreasing temperatures. So both show increasing and decreasing temperatures. Another comparison is that both graphs are nonlinear. We learned that from our last section. So they are nonlinear. And for number 3, Belfast was warmer at the end of the day than at the beginning. And Newport was colder at the end of the day than at the beginning. So now we want to try the on your own on the next page. So the graph shows the path of two birds diving to catch fish. We're going to describe the path of each bird. So we're going to start with the pelican. Pelican is the first graph. If you notice, it decreases at a constant rate. Dives down, and glides above the water to catch the fish. Of course, you could interpret it a little bit different. That's how I interpret it. Next, we have the osprey, located on the right side. It decreases at a steady rate until it sees the fish and dives into the water after it. So, three comparisons from the graph or from the graphs. First one, the osprey has two linear sections, but both graphs are nonlinear. So, both graphs are nonlinear. The second, the pelican has a smoother descent than the osprey. And the last, both are decreasing. So both graphs are decreasing. Continue on to example 2, sketching graphs. So to sketch a graph that represents each situation, we're going to start with letter E. A stopped subway train gains speed at a constant rate until it reaches its maximum speed. It travels at this speed for a while and then slows down at a constant rate until coming to a stop at the next station. So there are two steps when doing this. Step number 1 is to draw the axes, meaning the X and Y axis. And then label the vertical axis speed. And the horizontal axis will be time. Step number 2 is to sketch the graph. Well, I'm going to change different colors throughout. So in order to sketch the graph, I need to go back and read letter E. A stop subway train gains speed at a constant rate until it reaches its maximum speed. So a stop subway gains speed at a constant rate until it matches its maximum speed. So I'm going to show that in pink. Then it travels at a constant speed for a while. Then slows down at a constant rate until it comes to a stop at the next station. Oop, sorry, accidentally deleted my accesses. Um, but that can be an example. So, letter F. As television size increases, the price increases at an increasing rate. So, step 1 is to draw the axes. Then we are going to label the vertical axis price and horizontal axis TV size. So the vertical axis, I'm going to label that with price. And then the horizontal is the TV size. Step number 2 is to sketch the graph. So as the television size increases, the price increases at an increasing rate. So the price, let's say it starts here and it's just going to increase from there. This time it's just one color. So let's try it on your own. Sketch a graph that represents the situation. Letter G. A fully charged battery loses its charge at a constant rate until it has no charge left. You plug it in and recharge it fully. Then it loses its charge at a constant rate until it has no charge left. All right, so first step is to draw our axes. Then to label. Well, fully charged battery loses charge at a constant rate. Okay, so we're going to talk about the charge as the x-axis or the horizontal axis, and the y-axis or the vertical axis is going to be I apologize. I apologize. The x-axis is going to be time, and then the y-axis is going to be battery charge. Now for this one, I am going to add in this, that at this point, this means the battery is going to be full. So a fully charged battery loses charge at a constant rate. A fully charged, oop, oop, I apologize. There we go. A fully charged battery loses its charge at a constant rate until it has no charge left. Technology. So I'm going to display this by going down in a straight line. So that first sentence I'm underlining in green so that matches up. Next, you plug it in and recharge it fully. Then it loses its charge at a constant rate until it has no charge left.